Welcome to Module 5, and in this module we'll be looking at different resources that are available online to do such things as converting from one time base to another, being able to determine the predicted times of exoplanet transits, and being able to determine the necessary parameters that will later be useful when we're doing exoplanet transit modeling. There are a couple of good websites for doing conversions, for example, from local time to Julian date universal time, as you see here, and also for converting from Julian date to baryocentric Julian date. These resources, online resources, are useful. However, it should be noted that when we actually get into doing exoplanet observations, the software itself will take care of doing large-scale number of conversions, but these might be of interest to you if you just wanted to see, for example, for some sample times, what the differences are from between the different time bases. Now, if one wanted to predict when exoplanet transits will be taking place, there's a couple of websites that are useful to be able to do that. One is the NASA Exoplanet Archive. And on this website, if one wanted to determine, for example, the transits that are observable during a certain observation window at a certain location, one simply enters the universal time that one is interested in and the latitude and longitude of the location. The website will then produce a table showing all of the different exoplanets that are available for that particular time period and that particular location. Here I've highlighted in the table one particular exoplanet candidate, Kelt 1b, to show that the table presents the period of the orbit of that exoplanet, in this case 1.2 days, as well as the duration of the transit of the exoplanet across the host star, and also the midpoint, ingress, and egress times, each in terms of calendar date and their corresponding universal time. So this website will be useful if you wanted to see on a particular date at your location, what are all the different exoplanets that are available. What I've indicated here in this little pop-up menu, in fact, allows you to select what columns you would like to be displayed in this table. There are many other options not shown here, but there's a lot of flexibility as to what you can see about each individual exoplanet predicted observation. Now, also, this website allows you to click on a particular exoplanet. Let's say we were to click on, for example, Kelt 1b. What then is presented is an overview of the planet properties as well as the properties of its corresponding host star. So here's some more details about Kelt 1, for example, including a reference to its original discovery paper as well as follow-up papers. More information about the parameters of the planet itself, and also some information about the star that the planet is orbiting. Some of this stellar information will be seen to be useful as input when we're doing exoplanet transit modeling. Another useful site is the Exoplanet Transit Database, the ETD database, which is run by the Czech Astronomical Society. And again, one would put in one's longitude and latitude, select a particular date, and one would see the different exoplanet transits that are observable at that location for the particular day selected. And just as we saw previously, There's an observation on October 30th. Again, it shows the begin time of the transit, the center point of the transit, the end time of the transit, the duration of the transit, the magnitude of the host star, and the depth of the transit. Now, you will find that from one prediction site to another, such as between the NASA site and the ETD database site, the prediction times might actually be a few minutes off. And that is due to a number of reasons, one of which might be due to the fact that each site is using a different beginning time as to their predictions, but generally they're within a few minutes of each other. Another feature of the ETD website is to see historically what have been the observations of a particular exoplanet. So here we see observations of Kelt 1b, for example, over a period of about 5 years. Now, the interesting thing to note here is you see sort of a declining difference between what was predicted by the original discovery paper and what observations are being seen in subsequent years. It turns out, interestingly, that this decline is due to the fact that the original prediction of the period was off by just a second or a second and a half, and therefore that causes cumulative error to develop that you see here. Another feature of the ETD database is that for a particular exoplanet, if you put in, again, your longitude and latitude, you will see all of the upcoming transits that are predicted for that particular exoplanet. The ones in black are the ones that are observable from the site that you indicated here. The ones in gray are those that are observable from other locations. So here again, we see on October 30th, this particular transit opportunity for Kelt 1b. Another website that's useful for obtaining some of the parameters regarding exoplanets and their corresponding stars is the exoplanets.org database. And here one would put in the search field the indication of the exoplanet, and one would then get the different parameters associated with the exoplanet itself, as well as its corresponding host star. Now, not all exoplanets are in this particular database. In fact, Kelt 1b, for example, is not, but I'm showing here as an example, Kelt 2a small b. Now, some of the parameters that we find from these databases are important, as I said earlier, as input into the exoplanet transit modeling that we'll see later. And in particular, there's 3 that have to do with something called limb darkening. If you imagine an exoplanet transiting across the face of a star, as it's going across the star towards the edge of the star, there's the light from the star itself is actually going through many layers of atmosphere of the star. So there's a natural darkening, if you will, around the limb of that star. In order to compensate for this, when we're trying to accurately measure the change in brightness, the characteristics of this limb darkening need to be included in the exoplanet modeling. The limb darkening itself is a function of the temperature of the star, its metallosity, and its surface gravity. These parameters, in fact, are ones obtainable from either the NASA Exoplanet Archive or the exoplanets.org database. These 3 parameters plus the filter used determine what are called limb darkening coefficients. And if one has these parameters, there is a website that is operated by Ohio State that allows for input of either the planet itself and a filter, and submitting this query will have the limb darkening coefficients displayed, or if the planet is not in the database that ExoFast uses, one can directly input the stellar properties of the corresponding host star and the filter. Submitting the query will also get the limb darkening coefficients. And these limb darkening coefficients, again, are ones that will be input into the exoplanet transit modeling. So that concludes this module, and in the next module, we'll be going through in detail the various phases involved in doing an exoplanet observation.